In the depths of industrial warehouses that operate nonstop day and night, a silent and precise journey transforms mountains of used plastic into new raw material. It's not magic, it's a sequence of machines and steps that repeat on a gigantic scale, dealing with what society discards every day. Let's walk this path together, from the moment the raw material comes in through the door until the moment it leaves ready to return to the production line. Music. You separate plastic, throw it in the right bin, feel like you've done your part, but then what happens to that bottle after the truck disappears around the corner? The answer is more complex and much more interesting than any recycling campaign has ever shown you before any machine even touches a single piece of plastic. There's a stage that most people never imagine. The battle for raw materials in countries like Brazil, which is huge. Of all the plastic that reaches recycling centers, it doesn't come from municipal selective collection. It comes from waste pickers, men and women who go through streets, landfills, and dumps. They separate materials with their own hands, selling them by the kilo to cooperatives that resell them to industrial plants. It's this invisible chain that feeds a large part of the recycling industry in the country. Without it, the system stops when the material arrives at a sorting warehouse. The environment is noisy, sometimes slow, sometimes fast. Pressed bales of plastic, the size of refrigerators, are opened and thrown onto conveyor belts. From there, line operators manually sort at an industrial pace, identifying the type of plastic by touch, color, and markings, and throw each piece into the correct compartment. In more modern facilities, infrared sensors automatically detect the composition of the material, and jets of compressed air divert them to the correct chutes in fractions of a second. But even in the most technologically advanced plants in the world, the human eye still hasn't been completely replaced. And this is where the first big problem that nobody tells you about begins. Not all plastic is the same. There's a numbering system from 1 to 7 stamped in triangles on the packaging, and each number represents a completely different polymer with its own chemical composition, its own melting point, and its own industrial behavior. Mixing the wrong types in the process is like pouring water into hot oil. The reaction isn't what you expect, and the result is useless. PET, number 1 from soda bottles, is the industry's favorite. It has a market, technology, and buyers. HDPE, number 2 from detergent bottles, does too. But then you get to PVC, number 3, and things change. This guy, when heated, it releases chlorinated compounds that corrode equipment and contaminate entire batches. Many recycling companies simply refuse to process it. Styrofoam, expanded polystyrene, number 6, is technically recyclable, but the problem is that it's 98% air. Transporting styrofoam is like transporting almost nothing, but paying as if it were something. The logistics cost just doesn't add up. Most of the styrofoam discarded in the world is not recycled. This means that when you throw a styrofoam cup in the recycling bin, there's a real chance that material will go through the entire collection chain, use up truck fuel, take up space in the warehouse, and end up in the landfill. Either way, the material that survives sorting still has a battle ahead. Cleaning. Dirty plastic can't be processed. Food residue, grease, protein, all of that contaminates the polymer product and degrades the quality of the final product. Here's something few people realize. The bottle you washed at home before throwing it away has a different industrial fate than the one you tossed out full of grease. The quality of the material that reaches the recycling plant depends directly on what the consumer does before discarding it. The industry knows this, takes it seriously, and still can't control it. With clean and dry material, the real transformation begins. The plastics go into industrial mills, machines with rotating blades that grind everything into small fragments called flakes. It seems simple, but temperature control here is critical. Friction generates heat, and excessive heat degrades the polymer. Even before it reaches the next stage, a poorly calibrated mill can ruin tons of material in a matter of hours. In industrial plants, the shredded plastics go through washing tanks with hot water, industrial detergent, and mechanical agitation. Then centrifuges spin the material at high speed to expel the water. The process consumes large volumes of water, and this water, when it leaves the process, carries residues that need to be treated before being discarded. Recycling generates its own waste. That doesn't show up in the brochures. The flakes go to the extruders. These machines are the heart of mechanical recycling. They work like large heated screws inside a metal cylinder. The plastic enters solid from one end, is gradually heated as it moves forward, and comes out melted from the other end. Before coming out, it passes through fine mesh filters that retain impurities, pieces of metal, dirt particles, and residues of other polymers that escape sorting. On the outside of the extruder, the melted plastic is forced through a die with dozens of tiny circular holes. Thin, hot, shiny threads come out, which immediately plunge into a cold water bath. Within a few meters, they solidify and a rotating knife cuts them into small, uniform cylinders. These are the pellets, the recycled plastic granules. It's in this form that the material has commercial value. This is how it is sold, transported, and used as raw material by the industry. But what exactly is done with this recycled plastic depends on the quality. High purity PET. It can become a bottle again. For that, it needs to go through additional decontamination steps, including prolonged thermal treatment at a controlled temperature to eliminate any trace of chemical migration. The sanitary standards for plastic that will come into contact with food are strict, and not all recycled material can meet this standard. Intermediate quality material is turned into construction pipes, shoe soles, vases, automotive parts, and tool handles. Lower quality material, which is very mixed or already degraded by multiple cycles, is used in the composition of plastic wood. And what happens to what is no good? The rejects, everything that was discarded during sorting, everything that contaminated a batch, everything that didn't have a buyer in the market, they go to sanitary landfills in some countries. They go to industrial incinerators, which generate energy from the controlled burning of plastic. Germany, Japan, and Sweden have been using this process on a large scale for decades. In Brazil, it is still a subject of regulatory debate. The harsh reality is that not all the plastic that enters a recycling facility comes out as a recycled product. An inevitable part becomes process waste. The actual utilization rate varies and is rarely disclosed transparently. And that was today's video. Don't forget to leave a like and subscribe to the channel.